Okay, we're going to do number 6 on the Unit 7 review. So this is the same scenario as I think it was example 4. Fast food restaurant has installed new automatic ketchup dispenser for use in preparing its burgers. The amount of ketchup dispensed by the machine follows a normal distribution with a mean of 1.05 ounces and a standard deviation of 0.08 ounces. What's the z-score? So I'm looking at A. What's the z-score for when that machine dispenses 0.94 ounces of ketchup? So we have a little sketch over here on the right, and we have the mean in the middle. 0.94 ounces. I'm just going to mark that on the sketch. 0.94 ounces of ketchup. It just wants us to find the z-score. It's not asking for a probability or a percent or anything. Just what's the z-score. So a z-score is the value minus the mean, which is the distance from the value you're at from the mean. And it's in terms of how many standard deviations that is. So then you divide by the standard deviation. So we would take 0.94, that's the x value, minus the mean is 1.05, divided by the standard deviation was 0.08, and that was negative 1.375, but we're going to round to 2 decimal places, so negative 1.38. So again, it's just asking for the z-score. You do not need to go to the table and get a percent or proportion or anything. It says, what is the z-score? That's the z-score, negative 1.38. And then explain what the z-score means in the context of the problem. So a z-score is how many standard deviations a value is from the mean. So we would say something like 0.94 is 1.38 standard deviations below the mean. And I'm saying below because it's negative, and you can see on the picture that it's below the mean. So 0.94 ounces of ketchup is 1.38 standard deviations below the mean amount of ketchup. For B, what percent of the time does the machine dispense less than 1.11 ounces of ketchup? So I'm going to mark 1.11 on our little picture. What percent of the time does the machine dispense less than, so I'm going to shade less than, I want to find this percent. So I do need to find a z-score, and then this time I'm going to use the table, I'm going to look up that z-score and then figure out the percent. So it's the value, 1.11, minus the mean, 1.05, divided by the standard deviation. I'm going to put that in the calculator. I got 0.75. Make sure your z-scores are making sense. I should be getting a positive z-score because my value is above the mean, so it makes sense that my z-score is positive. In the last problem, 0.94 was below the mean, so I got a negative z-score. And then we're going to use the table and look up 0.75 and figure out, the table is going to tell us that shaded area, that percent. I'm going to go over the table. I'm looking for positive 0.75 here. So these are all negative. I'm going to go to the positive z-scores, positive 0.7, and then we want 0.75. So if I go along the top, I'm looking for where the 5 is in the hundredths place. So I'm going to that value right there. 0.7734 is what I want. So I want 7 in the tenths place, the 5 in the hundredths place for 0.75. So 0.7734 is this area. Sorry, my pen's not working. Hold on. And then I'm just going to change that to a percent because it says what percent of the time. So 77.34%. Okay, and then the last one, what percent of the time does the machine dispense at least 1.15 ounces of ketchup? I'm going to erase these marks on my picture. Okay, 1.15, that's up here above the mean again. It says at least, at least. That means that value or more. So I'm looking for this area above. I'm going to get a z-score, the value minus the mean, divided by the standard deviation. I'm going to put that in my calculator and see what I get. $1.25. I'm going to go to the table and look up 1.25. Again, it's positive. Here's positive 1.2, 1.20, 1.21, 1.22, 1.23, 1.24, 1.25 would be here. 0.8944. Okay, so that's this area. So make sure if it's asking for greater than or at least, we don't want to leave it like that. We want to do 100% minus, I'm going to put 89, I'm converting the 0.8944 to a percent. And just subtract those. And then that's the answer.